Hey developers, welcome to Devcovery. Today, we're bringing you the hottest open source projects trending on GitHub, so you don't miss any tech developments worth your attention.
Today, we're taking a deep dive into a trending project on GitHub, VoxCPM, a powerful new tool for generating human-like speech. It can create voices in multiple languages, design completely new ones, or clone an existing voice with startling realism. We'll investigate what makes this tokenizer-free model so special and why it's gaining thousands of stars. Imagine creating a completely new human voice just by describing it in words. Or what if you could clone an existing voice with startling accuracy? An open-source project is now making this studio-quality power accessible to everyone, directly challenging the big, closed-source text-to-speech services and their high price tags. The project is called VoxCPM, and it comes from the developers at OpenBMB. It's a groundbreaking text-to-speech system, or TTS, built to generate incredibly natural, multilingual audio. The latest version, VoxCPM 2, has exploded in popularity, racking up over 22,000 stars on GitHub. At one point, it gained more than 1,800 stars in a single day. This kind of excitement signals a major shift in the open-source voice synthesis world, as developers are clearly hungry for powerful alternatives to proprietary cloud APIs. For years, developers working with speech synthesis faced a difficult trade-off. They could either pay for high-quality, closed-source services, or they could use open-source models that often sounded, well, robotic and lifeless. The reason for that robotic sound often came down to how traditional systems work. They break down speech into tiny, discrete digital pieces called acoustic tokens. This process can introduce errors and strip away the subtle details that make a voice sound truly human. That tokenization step has long been a fundamental bottleneck, limiting how natural a voice can be, especially across different languages. VoxCPM's big idea is to bypass this problem entirely. By generating continuous speech representations directly, it tackles the core problem of artificiality at its source, aiming for a much more fluid and lifelike output. So, how does it actually work? VoxCPM's design is built on a sophisticated hybrid architecture. A good way to think about it is as a four-stage assembly line for creating sound. At its heart is a tokenizer-free approach. Instead of chopping audio into rigid digital blocks, it operates in a continuous, fluid space thanks to a component called AudioVE v2. This method is key to preserving the subtle, almost analog-like qualities of a human voice. The core logic is driven by a diffusion autoregressive model. Here, a large language model, mini-CPM4, acts as the director. It interprets the text and any style commands you give it. It then passes those instructions to a diffusion model, which is like the performer, responsible for generating the final acoustic features. This clear division of labor allows for both deep understanding and high-fidelity generation. And here's a key engineering highlight. The AudioVE component has an asymmetric design. It can take a low-quality 16 kHz reference audio sample, but it directly outputs studio-grade 48 kHz sound. This effectively builds a high-resolution upscaler right into the pipeline, eliminating the need for any external tools. This technology has immediate, practical applications. A content creator could generate professional-sounding narration in 30 different languages without hiring a single voice actor. Game developers could design unique, emotionally responsive voices for their characters, all controlled by simple text prompts. Even marketing agencies could rapidly prototype different brand voices for a campaign. Getting started is also surprisingly straightforward. The project is available through a simple pip install, and generating basic speech takes just a few lines of Python code. For production use, it even integrates with high-performance serving frameworks like VLLM Omni, making it scalable enough for very demanding applications. The feedback from the developer community has been overwhelmingly positive. Many are calling it the first open-source model to truly rival commercial services in both quality and naturalness. The voice cloning and creative design features are frequently praised. However, it's not perfect. Some advanced users have reported occasional high-frequency audio artifacts. Others have noticed that the voice style can sometimes drift during very long passages. This feedback highlights clear areas for future refinement and engineering work. Despite all its power, VoxCPM is not without its challenges. The project's own documentation is very upfront about the significant risk of misuse for creating deepfake audio. This is a serious ethical dilemma that shadows all realistic voice cloning technology. On a more practical note, the creative voice design feature can be inconsistent, sometimes requiring multiple attempts to get a specific result. And then there's the hardware barrier. The model requires around 8 GB of VRAM for inference, which is a considerable hurdle. This limits its adoption on consumer-grade machines and edge devices, at least for now. In the end, VoxCPM represents the democratization of high-fidelity speech synthesis. By combining a novel architecture with a commercial-friendly open-source license, it empowers developers to build sophisticated, multilingual audio applications without being locked into proprietary ecosystems. This is a significant step forward for the world of creative AI.
That's all for today's Devcovery. We hope these GitHub trending projects spark some inspiration for your development work. You can find all the repos mentioned in the description below. If you enjoyed this episode, don't forget to subscribe to our channel. See you tomorrow at the same time.